And welcome to another video. In this video I want to take you through a project I got on the website, and it's how to use a backup broker. The idea is to improve message delivery. Now MQTT comes with 3 levels of quality of service: 0, 1 and 2, and 1 is the most commonly used. It's an acknowledge quality of service, so you get an acknowledgement to messages that you published. Now, and not only that, if you have a break in the communication, a break in the connection, then the message is queued with quality of service 1 if it hasn't received an acknowledgement. So when you come back online, the message actually gets sent. So quality of service 1 is quite reliable. Now, you can improve that reliability quite a lot by using high availability servers or high availability brokers. And if you go to any cloud provider, they provide this feature, high availability, in a similar way to what they do for web servers. However, it also comes at a cost, and it's actually quite a complex procedure, not on your part because you just send it to the broker, but on their part. Now, a simple way and a very cheap and effective way of improving the message delivery is by actually sending it to 2 brokers. And what we got here in this diagram here is an example, is that we have a client and it can send to a primary broker or a standby broker, and our receiving client subscribes to the primary broker and the standby broker. And what I'm going to do here is demonstrate 3 Python scripts for doing this, and doing it in slightly different ways. The first script we're going to look at is basically going to connect to both brokers. Sorry, it's going to connect to a primary broker, and if that broker goes down, then it's going to connect to the standby broker and send the message that way. The receiving client is always going to subscribe to both brokers. Now, to demonstrate this, what I've got is I've got 2 brokers running on my Raspberry Pi, and here they are there. You can see the one broker is using port 1883 and the other one is 1884. So basically they're using the same IP address but different ports, but they're 2 different brokers. Now, one of these brokers could be your own broker, the other one could actually be a public network broker. So very flexible, it doesn't make any difference where the brokers are. Right, so let's take a look at the script. This is the first script, and you can see here there's the broker 1, broker 2, and you can see the IP address is the same, it's just the ports are different. And I'm going to publish on this topic. Now, the public acknowledgements here, but I'm actually not using these, so this could be a refinement to the script to actually use the pubax, but I'm not actually using them in this script at all. I'm using version 2 client, but I'm actually using the version 1 API. I'm using the version 2 client, but I'm actually using the version 1 API, which is why I've got that there. And I've got a couple of lines here that print out the version what I'm using, and also the Python version that I'm using. Quite useful to add to the scripts. Okay, here are my callbacks here, and I'm not using the on-message callback. I'm just using the connect and the disconnect, really just the connect. And in the connect callback, sorry, there's callbacks. In the connect callback, all I do is set a flag, and basically this is used for testing the connection. Okay, let's go down here, and so here we have the main part of the code. We try to connect to broker 1. And if we connect to it, we actually start the loop, so we can actually process the acknowledgements. And if we don't, we've raised this flag here. Then we go down to this loop, this if connection, and if we've got a connection failed flag, in other words, this happened here, then we connect to broker 2. And if that happens, then we start the loop for broker 2. And if that can't connect, we just exit. So basically we connect to one broker. If it fails, we connect to the other broker. Very, very simple, very straightforward. And on the receiving side, then we have to subscribe to both brokers. But I'm not going to do the receiving side. So let me just run this script. And you can see here it's running. And it's actually running, and it's sending to the first broker. And if I show you there it is there. So it's actually sending to my primary broker. So now let me stop the script, and if I go over to and I'm going to stop the broker, and now I'm going to start the script again. And this time it connects to broker 2, and if I show you the pi, you can see here it's connected to broker 2. Very simple, very straightforward. Okay, so let's stop all that. And we'll get rid of that, we don't need anymore. I'll restart the broker, and we'll go on to the next. And as it says on there in the title, what we're going to do here is queue messages. So have I got a diagram to show you that? No, but let me just walk you through it. So basically what we're going to do in this one is we're going to connect to both brokers, and you can see the connections down here. Again, we're using the connection flags and the failed flags to indicate whether we've got a connection or not. And we're going to connect to both brokers, and then what we're going to do is, if one of the brokers fails, we're going to switch to the other broker. And if that broker comes back online, then we're going to switch back. So we're going to have a primary broker which is going to take the traffic. If that fails, we're going to switch to the second broker, and if the primary broker comes back online, we'll return to the primary broker. Now, what we're also going to do is, if they both fail, we're going to queue the messages, and you can see down here, this is the code that does it. This is basically an infinite loop. We're going to try the first one, and then we're going to publish on the first one if that works. So we're going to try the second one, and then we're going to publish on the second one. So if that doesn't work, we go to the second one and we publish on that one. Now you can see the code preceding this is basically to do with the queue. So before we actually publish, we empty the queue. So if there's something in the queue, we have to empty it. And we do this on both occasions. Now if both of these fail, which means both brokers are down, then what we do is queue it. Now I should change this actually to message. It's the same thing. To make this simple, what I'm doing is that I'm having a counter, and I'm sending the counter as a message, so we can actually see all the messages. And you'll see that when I run the script. And if we get to 10,000 in the queue, then we zero the queue. We zero the count. I should have actually zeroed the queue there as well, but that's by the by at the moment. So if you get the idea, we connect to both brokers. If one broker goes down, then we switch to the other broker. If both brokers go down, we queue it, and once they come back online, we empty that queue and we send the messages. Okay, so let's run it. Now these are just the warnings for the callback, so I'm not worrying about those. So we're connecting to both brokers. Connection to broker failed. Okay, so we quit. And the reason that happened is I was testing this on a different machine, and I switched to the Raspberry Pi, which is a different IP address. So let's correct the IP addresses. Okay, and run again. Okay, so we connected to both brokers. We connected to two brokers. We're sending on client 1. And if I just show you quickly the Raspberry Pi, you can see here we're coming in on here. Right, now what I'm going to do is I'm going to stop the first broker, the primary broker, and you can see I'm disconnected. Now I'm starting sending on client 2. And if I show you on the Raspberry Pi, you can see I'm receiving on client 2. Now I'm going to restart that broker, and you should see it switching now. There it is, it's back sending on client 1. Now to verify that you're getting all these messages through with no interruption, what you need to do is to subscribe with another client to the topic we're publishing on, which in my case here is B1 House Test. And you should see all those messages coming in the correct order. And the last one we're going to demo, let me close those first before I do that. It's basically the same as what we've just seen. It's going to do more or less the same what we just seen. The only difference is it's actually going to publish the message in JSON. And if I go down here, so there's the message, but it's actually going to publish it. You can see it here. We're going to publish the message plus the message count. And this basically makes it easier when we're subscribing to it to actually make sure that we actually are receiving all of the messages. Okay, so let's run this script, and okay, we're connected to both brokers. Again, we're sending the message, and now I'm going to stop the primary broker, and you can see I'm disconnected from that, but I carry on sending the messages. And then I'm going to stop the standby broker, and you can see and it looks like I'm sending the messages, but I'm not. I'm just sending them into the queue, so I'm queuing them. So now let me start the standby broker. Right, and you can see here now I'm sent back to sending the message. I've emptied the queue here, and I'm back to sending the messages. And you can see we've still got the same count. The counts as sequential. And if I start the primary broker back, it doesn't tell me on the script that I'm on the primary broker, but if I show you the Raspberry Pi, there's the primary broker there, you can see that's receiving the messages now. Okay. One more thing, what I almost forgot to demonstrate is the fact that there is a receive script there, so we can actually check that we are receiving the correct messages. So I've got the script running. You see I'm on count 140, and let me find that there's a receive script here, and it's just going to print out, it's not going to print out the entire message, it's just going to print out the counter. So if I run it, it's also got a little error check in there to make sure that we are sequential. So if they not sequential, it will actually produce an error. You can see here. Okay, so let me run this module. And you can see the first thing it throws up is an error because it's expected to start from 1. It didn't. It started at 172. I've only got one broker connected, but that makes no difference. You can see here. Now if I actually disconnect the second broker, we're both disconnected. Because the receive and the sender is connected to the brokers, they both get disconnected. But now if I reconnect this one, the broker, you should see the messages come through again sequential. There you go. You can see them here. We stopped at 194 and then we carried on 195, and that happened very quickly, and then we came back onto the count. Okay, so as well the receive scripts also included in there. Okay, so that is the end of the video. If you've got any comments, then please leave them below. If you like the video, then click the like button, and if you'd like to get notified of new videos, then you can subscribe to the channel. Until next time, bye.